Okay, my friends, in the second hour, we are just going to make a few comments on the less set and dictionary comprehensions that we have talked about in the previous hour. So, my friends, basically, what you can create with list, set, and dictionary comprehensions are objects, okay? So, in a list comprehension, we are creating a list object. In a dictionary comprehension, we are creating a dictionary object, and in a set comprehension, we are creating a set object. So, we are using this when we intend to create a list, set, or a dictionary object, okay? But you can also create these objects using ordinary for loops, okay? Unless you are asked to do it by a comprehension, you are free to create these objects in any way you like. However, in some exercises or questions, I may ask you to especially to create a comprehension, then you are obliged to create the comprehension. However, if you are not asked to do it like that, you are free to use the ordinary for loop mechanisms, okay? Now, remember, we have used multiple target logic and nesting logic in list comprehensions. You can also use this multiple targets logic and the nesting logic when creating set comprehension and dictionary comprehension. So you can create a set of sets or a dictionary of dictionaries, and you can even nest one dictionary comprehension inside a list comprehension or a list comprehension inside a set comprehension. You can do those. However, these are left as an exercise for you. I'm not going to perform any examples on that. However, this nesting idea, the comprehension nesting idea, is not just limited to list comprehensions. It is also applicable to any kind of comprehension. You can nest one comprehension type of comprehension into another type of comprehension, and you can also apply multiple targets logic. Okay, now at this point, I'm just going to focus on what kind of advantages and disadvantages we get when we used comprehensions to create lists, sets, and dictionaries. So firstly, we should say that comprehensions are very abstract tools to create lists, sets, or dictionary objects. So this is called the conciseness property of comprehensions. They are very concise. They are very easy, okay? They are very abstract. So you do not need to write a sequence of command lines or a large code block to create a list object. You can do everything in a single command line, okay? And they are also expressive. What does that mean? A comprehension is an expression that creates an object. However, a for loop is just a body of code, okay? So for loops are, they have a larger or a wider application area. However, in comprehensions, we are basically defining an expression that creates an object. Okay, it creates an object. So we need to understand that in for loops, we are not necessarily creating objects. However, in these comprehensions, we are creating objects, okay? As an example, a list comprehension can directly be introduced as a value in a dictionary object. However, with a for loop, you need to create the list object first, then you can pass the variable bound to the list object to the dictionary as a value. So please check. We have practiced this in one application here. Instead of using the dictionary comprehension to invert the dictionary, if I intend to do it with a for loop, as you can see, first I need to create that dictionary as an empty dictionary here, okay? If you do not create it, here the assignment will not work because we are searching for a V key in the square root dictionary here, but if the square root dictionary does not exist, then the for loop will not understand in which dictionary that is going to embed this value key, the key value pair in the V value and key form. Therefore, please check here in this example. I want to create an exponent dictionary here, an exponent dictionary. In this exponent dictionary, we have three lists. Okay, there will be three lists: square, cube, and sorry for that, it says quartic, but it should be, yes, it should be quartic. Yes, you are right. Okay, square, cube, and quartic. Here, basically, I am creating a dictionary, okay, a dictionary which contains three keys: square, cube, and quartic, and the values are basically lists which are created by list comprehensions, okay? So I say my square key will be associated with a list of squared integers from 0 to 9. My cube key will be associated with a list with values which are the cubic versions of the integers from 0 to 9, and quartic will be associated with a list object which is obtained by the fourth power of all integers from 0 to 9. Okay, so this is a very, very expressive statement in which the objects are created by list comprehensions in the values of this dictionary object. Okay, and the third advantage is what? The performance. Now we can compare the following two programs which practically perform the same operation here. In this first operation, I am basically calculating the square root. I am calculating the square root of all integers starting from 0. Okay, all integers starting from 0 until 100 million. Okay, 100 million is not included, obviously. Starting from 0, 99,999,999 is the last integer. For all integers here, which are basically 100 million integers we have, for all 100 million integers here, I am calculating their square root and appending the square roots into that list, and I am printing the last square root that I have calculated, which is 9,999 point something, okay? Which is not exactly the square root of 100 million, because 100 million is not included in this square root calculation. Now, this is my first program. Now, I can also do this with a list comprehension, as you know. I can say that X is a list, which is the mapping of the assignment target to the square root function, okay? And the assignment target will take values again in the same range object from 0 to until 100 million. 100 million is not included. Again, I can print the last square root that I have calculated. Now, the second program, my friends, is faster. The execution time is less in the second one. In the first one, it is 40% larger. Okay, in the first for loop, it is 40% larger to execute the total for loop in this first program. Therefore, we should say that if we are creating a list object using a for loop, our code in Python will work faster if we create it by a list comprehension. Okay, but still, I mean, if the time is not an issue for your program, then you can use an ordinary for loop. The performance, the speed performance of a comprehension approach is much better. However, there are disadvantages as well, and that disadvantage can be summarized in incomprehensibility. Okay, though the name of a comprehension is called comprehension, okay, but it can be incomprehensible in a very faster manner. Okay, for example, in the application in which we have created the distance table, if you remember the distance table by using nested list comprehensions, the construction was not very comprehensible for another programmer that will read your program. Okay, now I have explained how this works to you here. I have explained how we can use nested list comprehensions to create the distance table here. Once explained, you can understand it, or once you build it by yourself, you can understand it. But if another programmer is going to work on your program to create, to understand your code, nested list comprehensions, nested comprehension structures are a little bit incomprehensible. Therefore, if you want for other programmers to be reading your code and understanding your code, my friends, using so much list comprehensions, this dictionary comprehensions and set comprehensions in nested structures are not going to be very friendly for the other programmers. Okay, so the golden rule of programming is what? Simple is always better than complex. Okay, this is the rule of thumb for a programmer, that we should always keep it simple. Therefore, if you are creating a list comprehension in the nest, if you are just going to create a nested list, it's not a very good idea to do it. Even if you are very clever to do it by a nested list comprehension, it's much better if you create it by using a ordinary for loop for another programmer to read and understand your program, okay? Unless the comprehension is very simple, using a for loop should be your first choice instead of a comprehension. This is the final note about the comprehensions. Any questions about these, my friends? Any questions about these suggestions, recommendations, advantages and disadvantages of comprehensions? All right. So I'm just going to take my tea and I'm just going to come back. All right, my friends. So I'm just going to follow with the while loops now. Okay, we will focus on while loops. Remember, in the beginning of this presentation slide, in the beginning of this module, we have mentioned about the Fibonacci sequence, which was obtained by appending a next element as the sum of previous two elements, if you remember. So 3 is the summation of 1 and 2, 5 is summation of 2 and 3, 8 is summation of 3 and 5, 13 is summation of 5 and 8, so on and so forth. It goes like this. Okay, so remember, one question that we have asked previously was what? What is the 50th element or 100th element or 500th element of the Fibonacci sequence? And we have said that we can simply create a for loop to evaluate these indices in the Fibonacci sequence. Remember, the Fibonacci sequence starts at index 0. So index 0 is 0, index 1 is 1, index 2 is 1, index 3 is 2. It goes like this. So the indexing for the Fibonacci sequence also starts at 0. Now, I am going to ask a different question this time, okay? Different question. Here I say, what is the first index that we observe a Fibonacci number in the sequence that is greater than 10 to the power 12, okay? So here, this is my first question. The Fibonacci sequence goes like this, is increasing, obviously, because every value is the sum of the previous two values, and the previous two values are also positive. Therefore, a Fibonacci sequence is an increasing sequence, and at some point it will pass, a number will pass 10 to the power 12. So I am interested in the index of the Fibonacci sequence in which the value, the previous index has a value that is less than 10 to the power 12, but that value is greater than or equal to the 10 to the power 12. What is the first index which yields me a Fibonacci number that is greater than or equal to 10 to the power 12? This is my first question, okay? How about the second question? Now, please check. I have a ratio here, which is the ratio between the last element of the Fibonacci sequence to the previous element, okay? For example, 2 over 1 is 2. 3 over 2 is 1.5. 5 over 3 is 1.67. 8 over 5 is 1.6. 13 over 8 is 1.625, so on and so forth. Okay. Now, it is quite easy to prove, but we are not going to prove that. It is quite easy to prove that eventually, if you continue this Fibonacci sequence so long, this sequence in which we divide the last element to the previous element of the Fibonacci sequence will also converge to a certain value, okay? It will be converging to a certain value, and I am interested in this. If I continue the Fibonacci sequence for so long, in that case, what would be the ratio between the last element to the previous element? So that is the ratio of the last element to the previous element as the Fibonacci sequence goes to infinity, okay? Now, for the first question, I need to create a Fibonacci sequence until the point where I get a first Fibonacci number that is greater than or equal to 10 to the power 12. But for the second one, in order to answer the second one, I need to create a Fibonacci sequence until the infinity, or maybe I do not, okay? So we are going to answer these questions. But in order to answer these questions, for loops, my friends, are not convenient looping mechanisms to use. So instead, we are going to use another structure, another looping structure, which is a little bit different than the for loops, which is called a while loop. Okay. No, please check. I am interested in calculating the first Fibonacci number exceeding the threshold t. That threshold t was 10 to the power 12 in this question. Okay, that threshold t was 10 to the power 12 in this question. However, I'm just making it much more general here. I say that what is the first Fibonacci number, or what is the index of the first Fibonacci number which exceeds t, which means the previous value will be less than or equal to t, but the next value will be greater than t. Okay, so once I satisfy such a condition, I will return the index n as the first Fibonacci number, or the index of the first Fibonacci number that exceeds a certain threshold. So this is the flow chart of the program that I need to write. It says, define the threshold t first. So let's just say t is 10 to the power 12. Okay, such that t is greater than or equal to 2 and an integer. Okay, I'm sorry, by the way, threshold, threshold is not necessarily to be an integer, but it says t is greater than or equal to 2 an integer. Maybe I will correct it later on, okay, but it doesn't make any difference here. So I know that the first value that is greater than or equal to 2 is the third index. So I am not very interested in for a threshold that is very small. I am interested in very, very large threshold values, like 10 to the power 12. Then I initiate my Fibonacci sequence as the 0 index as 0, as the first index as 1. And right now I have index 1 as evaluated. Okay, n is equal to 1, f1 is evaluated. Okay, we know the first index of the Fibonacci sequence. Then I write a decide module here. This decide module is diamond shaped, and it basically contains a Boolean expression. It says, if the current index n, for current index n, if the Fibonacci number at the end index is less than or equal to threshold, in that case, I need to continue my sequence. Okay, I need to continue my sequence. Otherwise, I will reach to my point where fn is greater than t. Then I will return the index n. Okay, so I say currently for n equal to 1, fn is equal to 1, and 1 is definitely not less than or equal. If 1 is definitely less than or equal to threshold, therefore I continue to here, and I say update n as n plus 1, which means increment n. N now becomes 2. Previously it was 1, n becomes 2. And for the second index of the Fibonacci sequence, f2, I evaluate f2 as the summation of f1 and f0. And then I return to my decide module again. And I check the last number in the Fibonacci sequence that I have evaluated. Is it less than or equal to t? If it is yes, again, I will increment n by 1, and I will evaluate the next Fibonacci sequence, so on and so forth, until the last element that I have added to the Fibonacci sequence is greater than t. Whenever it is greater than t, I will simply return the index, which for the last index that I have evaluated. Okay, this is the flow chart for the Fibonacci. For the index which exceeds a certain threshold for the first time. Now this is the program that I'm going to write. This is the program that I'm going to use. I will explain this program, my friends, in Spider, because it is just going to be much more comprehensible because of the coloring that let's erase those. And no, okay, all right. So I enter t as a Fibonacci threshold, okay, and this is going to be passed by the user as an input. And remember, the input function returns on strings. Therefore, I need to convert that the passed input into an integer. So t is the threshold for which we are interested in the first index, which is exceeding that threshold. Then I say my Fibonacci sequence is initiated as a 2-element list, which contains the 0 Fibonacci number and the first Fibonacci number. Okay. Then I write a while loop. Okay, I create a while loop. I say while while Fibonacci sequence's last element is less than or equal to 2. Right now, the last element is 1. Okay. While Fibonacci sequence's last element is less than or equal to 2, evaluate the next number in the Fibonacci sequence as the last two element summation. Fibonacci sequence minus 2 and Fibonacci sequence minus 1. The last two elements are summed up as the next number, and I append the next number into the Fibonacci sequence. Okay. So this is the code block of the while loop because these two command lines are indented. Remember, when they are not intended, this is out of the while loop. Okay. Now, after I append the last value, the while loop will repeat itself and it will again check if the last element, the current last element this time, is less than or equal to the threshold. Unless the condition is not satisfied, the loop will repeat itself by appending new numbers to the Fibonacci sequence again and again. But once the last element that is appended to the Fibonacci sequence is greater than the threshold, the while loop will terminate. I will get out of the while loop, and there will be an output text that I will be creating in the form of an F string. I say smallest Fibonacci number that exceeds T. T is given in placeholder, so here T will be written in numeric value, is, then I concatenate my output text again with another F string, is the last element of the Fibonacci sequence in a placeholder, comma, and there's a new line here. There's a new line here. It says, which is observed at index len Fibonacci sequence minus 1. Okay. So the last index of the Fibonacci sequence is obtained by calculating its length in list, and I subtract 1 from that, which gives me the last index of the element, the list object that I have. Then I print output text. So let's say, what is your Fibonacci threshold? It says, I write here 12 zeros. Okay, 12 zeros, 10 to the power 12. And I press enter. It says the smallest Fibonacci number that exceeds 10 to the power 12 is something like this. Okay, I cannot even read it, which is observed at index 60, it says. In the 60th index, this value is observed. Okay. Now, in fact, at this point, if I print, let's just say FibSec, I am interested in printing last three indices. Okay. Let me write 10 to the power 12 again. As you can see, the 60th index passes 10 to the power 12, but the previous two indices, the previous index, it gets very close to 10 to the power 12, but it does not exceed it. Therefore, 60 is the first index that returns me a value, Fibonacci number, that is greater than 10 to the power 12. Okay. Did you understand this very, very easy structure of the while loop, my friends? Yes or no? Do you have any questions?
Yes, hocam.
I think you are good. All right. So I'm just going to close this and come back to my presentation file. Now, let's mention about the general structure of a while loop. Now, in a while loop, we start with keyword while. While is a keyword like for, okay? After the while, we write a Boolean expression, okay? Unless the Boolean expression is, if the Boolean expression is true, then the indented code block under the while loop will be repeated, will be performed, okay? Obviously, when the code block is performed, it will update some contents related to the Boolean expression. So it may be possible in the next repetition of the while loop that the Boolean expression may return a false, okay? So if the Boolean expression in the while loop remains true, this code block will be repeated again and again and again and again, unless at some point the Boolean expression will return a false. Whenever it returns a false, it will skip the code block. It will skip the code block in while whenever it returns false, and it will move to the next line in your program, okay, after the while loop, okay? This is the general structure. Now, in a while loop, my friends, the driving force is a Boolean expression. Okay, in a for loop, however, the driving force was the assignment target taking values in an iterable object. Okay, this is how while loops are different than for loops in the beginning. The driving force here is a Boolean expression. As long as the Boolean expression remains true, the code block in the while loop will be repeated again and again and again. Okay. However, you need to be careful in the while loop. The code block at some point must update some objects related to the Boolean expression. Otherwise, the Boolean expression will always remain true and your program will be stuck in this while loop. Okay, it will never ever terminate. Okay, so you see the Boolean expression must be exposed to a change in the code block. Okay, the value of one variable mentioned, at least one variable, not necessarily one, but at least one variable, the value of at least one variable in the Boolean expression must be exposed to a change in the code block so that at some point the Boolean expression is guaranteed to return a false result so the while loop can terminate. Now, we are going to look at the first example again here in this program. Okay, this was the first example, exactly the same. So we are basically understanding what's going on here again. I'm just going to repeat it again once you understand the structure. So there is a variable threshold. Threshold is a part of the Boolean expression. We assign this threshold as 10 to the power 12 in our program, okay? 10 to the power 12 in our program. And we have said that as long as Fibonacci sequence last element is less than or equal to t, repeat the code block in the while loop, okay? So the repetition of the while loop will append a new number at the end of the Fibonacci sequence list as the summation of the last two elements. And we know that because the Fibonacci sequence contains only positive values, the next number that is going to be appended will always be greater, okay, than the previous numbers. Therefore, it is guaranteed at some point that this last element will exceed the threshold. Now, please check again. In the Boolean expression, we are always using the last element of the Fibonacci sequence, which means we are updating the Fibonacci sequence list. Therefore, the Boolean expression has one variable here, which is associated with a value that is exposed to change in the while loop. Okay? If you do not do it like that, if at least one variable in the while loop is not exposed to a change in the while loop, in that case, either the while loop will not terminate, which means until infinity it will remain in the loop, okay? Or maybe by chance, before entering the while loop for the first time, the Boolean expression here may return a false in any way. In that case, it will skip the while loop in any way. So it may not even enter the while loop too. If the Boolean expression returns a false at its first check, then the while loop will be skipped in any way, okay? Therefore, you should be very careful how the driving force, the Boolean expression of the while loop, will be exposed to a change in the code block of the while loop. You need to be very careful about that. Now, we have written it carefully because the last element will always be increasing. At some point, it will definitely pass the threshold. This while loop terminates, okay? Now, my friends, at this point, we are learning, and it is quite possible that we are making mistakes in looping mechanisms, okay? Therefore, it is a good idea to write some print functions inside your while loops to understand what's going on in your while loop, okay? It's a good idea for a programmer to check if there is a problem with their while loop, if it really terminates. So we are going to utilize the print function inside the code block. And at every repetition of the code block, the print command line will also be executed and it will return us an information. Okay. Our program starts at, so let's just implement this in again here. Okay. So our program starts by assigning t value by the user input again as an integer value. Okay. And my Fibonacci sequence is initiated as a 2-element list with the 0 index and the first index of the Fibonacci sequence. And we are starting by calculating the second index of the list, right? Now, let me check if we have done this before, or is it really necessary to assign n? Yes, it's necessary. Okay. So in this case, we know that the next number, the next index that we are going to be evaluating is 2. We are basically storing it, n is equal to 2. And I say again, I create a while loop. The while loop will continue to repeat as long as this Boolean expression remains true if the last element of the Fibonacci sequence is less than or equal to t. And I evaluate in my for loop as the next number. Okay, the next number. The next number is the summation of the last 2 elements, as always. I append this next number to my Fibonacci sequence. Then I write a print statement for trace purposes. I say in an F string, at index n, we have the next number. So in the first repetition of the while loop, it will write, at index 2, we have 1. Okay. Then I increment n by 1. I increment n by 1 because the next number to evaluate in my while loop is going to be at index 3. Okay. So n is being updated in each repetition of the while loop again. Again, the for while loop here will terminate because it's no different than the previous while loop. It is based on the last element of the Fibonacci sequence and it will eventually exceed t. Therefore, it will terminate. However, at each repetition, it will write us at each index, what number do we have? So let's write it again. What is your Fibonacci threshold? So let's make our Fibonacci threshold this time a very small number like 100. Okay. So whenever the sequence has a number that exceeds 100, it will terminate. So please check. At index 2, we have 1. At index 3, we have 2. At index 4, we have 3. So you are basically getting a print comment here in each repetition, which basically gives you an information what the while loop is doing in each loop, in each repetition. And at index 12, we have 144 is also written. At this point, the while loop terminates and the output text will be returned as the smallest Fibonacci number that exceeds 100 is 144, which is observed at index 12. Okay? Did you get the idea of trace? So why we are doing trace? So let me explain why we are doing trace. Sometimes we write so complex while loops or for loops, and in fact, you can apply this tracing idea inside for loops too. Sometimes we write so complex while and for loops, which are nested one inside each other. Okay, in this kind of complex structures, writing a print comment with a actually good purpose, obviously. I mean, as an experienced programmer, you will define your print comment here, okay? So the best print comment that we can fit here is such a print comment, which gives us the current index that is evaluated and the number at that index. And you can see what's going on in computers' calculations using this trace option, okay? Trace is a good idea to understand. But once you are sure that your while loop works perfectly, you can then simply omit that command line like this. So the next time the program works again, it will not repeat these printed outputs, okay? So optionally, you can keep a print command like this. Once you get sure that your while loop works properly, you can just erase that command line, or simply you can say that the interpreter should omit that command line with this sign. Okay. Are we good? Did you understand the idea of trace? It's not a big deal, actually. It's not a keyword. The trace is not a keyword. It's just an idea for the programmers to read the calculations of the computer if they are working properly or not. Okay, at which repetition, if there is a problem, let's just say, at which repetition it does. For example, let's just say, instead of being less than or equal to t here, okay, the last element, let's just say I have written the first element is less than or equal to t. Okay, now if I do it like this, obviously I will get a logic error, but the program will work. So I say, as long as the first index is less than or equal to threshold, continue calculations. Okay, and it will infinitely, until the infinity, it will perform these calculations. Okay, now it is very fast. It is continuing to make calculations again and again, unfortunately, because the first index is 1 and it is always less than 100, and therefore my function does not terminate. However, you see that it is calculating index 3900, 950. We have this number. So you are getting the idea, right? Even the values are exceeding your result, your threshold, the while loop is not terminating. So you understand that there is a mistake in this while loop, which can be corrected by, so I need to stop it, which can be corrected by introducing -1 here to check the last index, and then my program terminates. Are we good? I think we are good. Okay. Now we have traced our executions, and even for a very, very large value, we have a finite number of print commands here working and showing us that actually the 59th index is less than 10 to the power 12, but 60th index is greater than 10 to the power 12. Okay. We can use this trace idea in developing functions, which we are going to study later. It is a very, very important idea, my friends, okay, to implement in your programs. Okay, now, my friends, sometimes we intentionally would like to break out of a while loop, okay? We intentionally would like to break out of a while loop. Sometimes we say that while loop should repeat again and again and again and again without a check on Boolean expression here. But inside the code block, I can write a if statement with that Boolean expression. If that Boolean expression is satisfied, we write a break command as indented, okay, as indented. And that break command, when it works, when this Boolean expression is satisfied, it will directly bring us to the next command line in our program, which will break us out the while loop, okay? Just like a prison break, okay? So, but this time we need to guarantee that this Boolean expression here should be eventually satisfied. So in this structure, we have a while loop, which starts with a Boolean expression that is always equal to true. So I say while true, which means this while loop will infinitely repeat itself, because this Boolean expression that I write in the while loop is always true. Okay, I especially written it as true. Okay, however, because we are going to use the break command, okay, the break keyword in our while loop, it will eventually break us out of the while loop. So I write after the true statement here, after the colon, I write my indented code block. I write a prior code block, which will be executed at every repetition of the while loop. Then I write an if statement with a Boolean expression. This Boolean expression, if it is true, if it is satisfied, then we write indented break keyword here. It will break us out of the while loop. But if it is not satisfied, the loop will also perform the posterior code block. Okay. Now, in its first repetition, if we cannot break out of the while loop, both prior and the posterior code blocks will be executed. In its second repetition, if the break cannot break us out of the while loop, if the Boolean expression is not satisfied, again, the prior and the posterior code block will be repeated. Okay. However, let's just say in the third loop of the while, we somehow have entered in this break if statement. If the Boolean expression is satisfied, we enter in this if block, and the break keyword has been executed. In that case, in the last repetition, prior code block will be executed, but posterior code block will not be executed. Okay, it will be omitted in the last execution of the while loop because we have broken out of the while loop before the posterior code block is executed. So let's do it in this case. In while loop 3, so let me show that here again. So again, I get the threshold index, the threshold for the Fibonacci sequence. I am interested in the first index in which we exceed the threshold value from the user converted to integer. Now this time I'm not creating a list, my friends. Why? I'm not creating a list. I say the previous number of the Fibonacci sequence was 0. The last number is 1. Okay. I am not storing these values in a list. Why I'm doing this, I'm going to explain later. Now I say the next index that I am interested in calculating is the second index. Okay. Then I write a while loop. While true, which means this condition is a redundant condition for the while loop to check, because this will always remain true. There is only one way out of breaking this while loop, a possible break keyword that can be executed in the while code block, okay, which exists, by the way, which exists here. So I say the next, as long as the while loop repeats, the next number will be the summation of the previous number and the last number. Okay, the next number will be the summation of the previous number and the last number. Just like in the last idea, the next number to be added is the last two, summation of the last two elements. Here I am also applying it. The next number is the summation of the previous number and the last number. Then I write my if block. If the next number is greater than t, colon, then break the while loop. Please do not forget that this should be indented. Otherwise, you will get an error. Okay. Now, when you are solving questions using the spider, it will warn you in any way, but there may be questions that you need to solve on paper in some of the exams. Therefore, please do not forget about this syntax. So in the first calculation, obviously, the next number will simply be equal to 1. Therefore, it is not greater than t. Therefore, we cannot break. Okay. Now, the posterior code block does what? It says, let the next index to be evaluated in the Fibonacci sequence would be n plus 1 incremented and as n plus 1. Okay. Right now, we have calculated the second index. Now, the next, we need to calculate the third index. The previous number will be updated as the last number, and the last number is updated as the next number. Okay. So my new last number is the next number that I have just calculated. And now my new previous number is the last number that I have calculated earlier. So in the end of this first repetition, the previous number will become 1. The last number will also become 1. And the next index that I am interested in calculating will become 3. So the while loop will repeat itself. Again, the next number will be calculated by using the last two numbers, previous number and the last number. Until the next number exceeds t, this if block will be omitted. And always the previous number and last number and the n values will be updated, so and so forth. Finally, whenever the next number is greater than t, I'm just going to break out of the while loop here, okay? And I will write the smallest Fibonacci number that exceeds t is the next number, which is observed at index n, okay? Now let's execute this function again for 10 to the power 12. It says at the 60th index, we observe the same number again, which exceeds 10 to the power 12 for the first time. Okay, so this while loop terminates by using the break keyword here. Okay. However, please check if I print n if I print n here, I'm not going to get a 61. Okay. I'm not going to get a 61. I will get 60 because the posterior code block after the break, my friends, is not executed in the last iteration. Okay. That is why n remains as 60. And obviously the previous number and last number values are also not updated because the last command line is not executed due to this break command line. Did you understand the idea, my friends? Yes or no?
Yes, hocam.
Okay. Now here's the thing, my friends. Why I have coded my program like this? Now previously, I was creating a sequence in the form of a list, and I was appending the last value that is evaluated as the next number. I was appending it to the Fibonacci sequence. I got a sequence in the end. Okay. Why I'm not doing this here? Because if I create a list, my friends, then the computer will allocate some space for that list, and this list will be appended by new objects again and again and again. So if I am interested in calculating the first index that exceeds, let's just say 10 to the power 12, I will be creating a list of 60 elements. And for a list of 60 elements, the computer must allocate some memory, right? Now, in such small programs that we have written here, it's not a big problem. But there may be cases where you need to create a list of, let's just say, 100 million objects. Okay? If it is not necessary to do it, then do not do it, because you do not have enough memory in your computers to store a list which contains 100 million objects, my friends. Okay? I mean, do not think about the capacity of your hard drive. You need to think about the random access memory. If your computer, let's just say, has 8 gigabytes or 16 gigabytes of random access memory capacity, in that case, it will not be able to create such list or dictionary objects which have a very large size. Therefore, my friends, it's much better to, if you are not interested in using the previous elements that you have evaluated in the Fibonacci sequence at some point, or if you are not going to use the list that you are going to create in a later part of your program, there is no necessity to store these values in a list. Okay, so that program saves so much space in the memory of the program, so we can use it for further instructions in our program. Did you understand the idea? Yes or no? Why we are not using lists here?
Yes, hocam.
Okay. All right. So let's move on then. Okay. Now we have seen an example on while loop, and we have seen many examples on for loops. We are going to see many other examples about while loops again later on. Here, we need to mention about the differences. So then we are going to give a break. A for loop is basically used when the number of iterations is known beforehand. Okay, the main difference is this, because in a for loop, the driving force is the assignment target, taking values from an iterable object, okay, taking the elements of an iterable object one by one. Since the size of that iterable object in a for loop is deterministic, we know that how many times the for loop is going to be repeated, okay? If the number of times that the for loop is to be repeated is, or the code block inside the for loop is to be repeated, is known beforehand, then a for loop mechanism is better, okay? But in while loops, when do we use while loops? We do not exactly know how many repetitions should we get here to calculate a Fibonacci number that exceeds the threshold, right? If the threshold is 10 to the power 16, we do not exactly know that this loop should be repeated 58 times, okay? Therefore, until the condition is satisfied, this while loop will be repeated. The difference here is this. In a while loop mechanism, we do not exactly know how many times the while code block will be repeated. Therefore, it is not deterministic, okay? So the driving force is a Boolean expression, and we do not know exactly at which repetition the Boolean expression will be satisfied or dissatisfied, okay? These are the two main differences between for and while loops. For loops are driven by an assignment target which takes values over an iterable object, while loops are driven by a Boolean expression. Whether that Boolean expression is written inside, whether that Boolean expression is written after the while keyword, or that Boolean expression is written inside the code block, inside the while block, under an if statement which contains a break keyword in it. Okay. My friends, let's give it 10 minutes of break right now. I'm stopping recording.